When performing the t-test, we assume that our data is normal. In the wild, you'll often encounter probability distributions that are distinctly non-normal. They might look like this, or completely different. As you'd imagine, there are still statistical tests that we can utilize when our data is non-normal. Why don't we briefly discuss what you might do in situations like this? First off, we should have some machinery in place for determining whether or not our data is Gaussian in the first place. A crude, inaccurate way of determining whether or not our data is normal is simply to plot a histogram of our data and ask, does this look like a bell curve? In both of these cases, the answer would definitely be no. But we can do a little bit better than that. There are some statistical tests that we can use to measure the likelihood that a sample is drawn from a normally distributed population. One such test is the Shapiro-Wilk test. I don't want to go into great depth with regards to the theory behind this test, but I do want to let you know that it's implemented in SciPy. You can call it really easily like this. W and P are going to be equal to scipy.stats.shapiro data, where our data here is just an array or list containing all of our data points. This function is going to return these two values. The first, W, is the Shapiro-Wilk test statistic. The second value in this tuple is going to be our p-value, which should be interpreted in the same way that we would interpret the p-value for our t-test. That is, given the null hypothesis that this data is drawn from a normal distribution, what is the likelihood that we would observe a value of W that was at least as extreme as the one that we see?